So let's move on from the connection layer to the data model layer. And so it's really important to understand the data model that Tableau is using. And this is a relatively new implementation of the data model that was implemented just a year or two ago in Tableau, in which they have introduced logical and physical views of your data. So the structure of the data model is determined by the table or tables, and here the term table is, as it relates to a database, but it's also interchangeable to worksheets in, for example, an Excel workbook. So the structure of the data model is determined by the table or worksheets you include on the data source page. In other words, the connections. And you can, when you have more than one table, when you have multiple tables that you want to combine, you can combine them using relationships, which is something that's new in Tableau, joins, or unions, right? You could use all of these things. So let's talk more about the logical layer and the physical layer. And you can see on the right-hand illustration, in the logical layer, multiple table data can be connected via relationships. So you can see there's a relationship between logical table A and logical table B. These two tables, table A and table B, remain normalized, which means that they're distinct, they're independent from each other, and that therefore they're able to maintain their level of detail, even if the level of detail or the granularity of the data in table A is different from table B. This is important, and this is something that's new in Tableau. New is about a year old, somewhere around that time frame. These logical tables in the logical layer are containers for physical tables that can be either singular or merged tables. So if you look at the physical layer, you could see that for logical table A, that's actually mapping to, in the physical layer, table A that is joined to three other tables. And then, so you have four source data or data sources that are joined together, and they are and that combination, we'll talk more about what joining does to the data, is what is contained in table A. So in that physical layer below, that is contained in table A, those things are combined or merged using joins and or unions. And then you could see that you could also have a physical layer that just contains a single table. In other words, that logical table B, which is just a single table, it's not joined or merged with anything else, it's still considered to be a logical table, and its physical layer just contains that single table. So it's important to understand this difference between logical and physical layers now in the new Tableau data model. So here's a short video on the difference between the logical and the physical layers. So in this short video, I want to show you an aspect of Tableau's data model. Here we're going to talk about the logical versus the physical view. In the logical view, that's what we are seeing right here in the data source screen. And I'm using the Superstore data set. And you should all be familiar with this. I dragged orders over, and now we have all of the order information. But what I'm going to also do now, and you should be familiar with this as well, is I'm going to drag returns over. And you'll see as soon as I do, and we'll talk more about this in another video, that as soon as I do, Tableau has created this little orange line, and they call it a noodle because it sort of looks like a noodle as you move it around. And what Tableau has done is it's created a relationship that you can see here, connecting the data, making a relationship between the data in orders and the data in returns. The level of detail of each remains the same, a row of orders and a row of returns. And you can see here, and we could obviously adjust this as we can in anything in Tableau, but Tableau is smart enough to go, okay, order ID from our orders table, if that and order ID from our returns table is how we're going to connect these two things together. But you'll notice that if I click on orders, I'm looking at the order data within this data source. And if I click on return, I'm looking at the return information in this data source. So that's the logical view. Both tables are in the view there. They're not merged together into a new data source that Tableau is going to use. If I click, what I did was I double clicked on the orders table, and now what I'm going to do is drag the people table over here and create a union. And as soon as I do that, again, Tableau is kind of smart enough to know how to create this union. And again, we'll talk more about all unions and etc. later on. You'll see that it's saying, hey, on the left-hand side, we're going to use region. On the right-hand side, we're going to use region. This is an inner join, so we're just going to include things where they both match. Now, if I scroll all the way over to the right, everything on the left-hand side is information from the orders table. Now everything on the right-hand side, and you could see here, if you look closely, the table name orders, and then it switches to people. So now we can see what we've done is join that person so we know who the manager is in the various regions. This is what's referred to as a physical view of the data. And when we close out, we're back at our logical view, and you can see that it's telling us now that orders is made of two tables, and now you could see Cassandra, right? You could see the manager's names, and we still have returns. So we have a logical view and a physical view of the data. All right, the next thing that I want to cover is the different data models that are supported in Tableau. I'm going to go through these fairly quickly because we're not going to be doing much with at least with some of the more complicated ones. Single table, that's something you're all very familiar with, a table that has different dimensions and measures. That's the superstore, example that again you should all be familiar with. There's something referred to as a star and snowflake, and that's where, for example, you could see customers contain dimensions and measures. Remember, dimensions are blue, measures are green. That's just the color coding that Tableau uses. And in the customer table, the dimensions are really just foreign keys that are can be used to relate to dimension tables, where there's this foreign key, primary key kind of relationship. So you could extract, or not extract, but relate the dimension information. You could have star and snowflake with measures in more than one table, and then you could have what Tableau refers to as multi-fact analysis. So it's important to understand that as a result of the new relationships that you can create in Tableau's data model, you can support all these different types of different data model structures. When combining data options, it's important to understand the different types of ways of combining data, either through relationships or joins or unions and blends. And we're going to talk about the top three in a little bit more detail. We're not going to spend much time on blends, but some of the key distinguishing characteristics are that when you create a relationship, it does not merge the data to create a new fixed table. It maintains the appropriate level of detail within each of the source data, the underlying data that is part of the relationship. A join merges two tables of data based on a join clause, so based on some common fields and a join type, and to create a new fixed table of data. And as a result, this could relate to some data loss depending on the different join types and may cause data duplication, especially if the tables that you're joining together are at different levels of detail. Unions are similar to joins in the sense that they are merging two or more tables of data to again form a new fixed table of data. But unions are used to append new rows of data across the same column structure.